In this video, we are going to understand how we can control a PMSM machine with the help of the direct and quadrature current control loops using field-oriented control algorithm. As you may know, the quadrature current component is responsible for the effective torque production of the electric rotary machine, while the direct current component can adjust the strength of the magnetic flux. The speed controller provides such requested torque value for the motor controller that can be converted to reference quadrature current value by using the general equation regarding the PMSM torque production. Afterwards, the quadrature current controller is responsible for maintaining such current in this direction to fulfill the needs of the reference value. The direct current controller shares the same importance as the quadrature controller does. However, it is responsible for constantly adjusting the direct current component value to achieve the desired resulting flux in the electric motor. If you feel a quick refreshment would provide a better understanding of this topic, check out slide 24, where you can obtain how the flux in the D direction can be altered, alongside with the pole flux of the permanent magnets. During this video series, we would like to control surface-mounted PMSM motor variant without a field weakening control algorithm. We are going to shortly align on the relevant input-output current regulator interface physical dimensions as we did in case of the speed controller. Let's have a look firstly to the direct direction. As you may see, the reference direct current as well as the feedback or actual direct current share the same physical dimension interpreted in amps. The controller's output is a requested voltage value in the direct direction that shall be further transformed to the three-phase coordinate system. This regulator is responsible for diminishing the pole flux of the permanent magnets in order to achieve the so-called flux weakening phenomena. The latter mentioned technique is an optimization possibility of the PMSM servo drives that we are not going to cover within this course content. However, I may create an independent video series about the most used optimization techniques regarding the permanent magnet synchronous motors in the future. Next is the quadrature current regulator. We are not surprised at all, the same physical dimensions are present in this current controller as well, as we saw in case of the direct direction. However, as we know, the quadrature current regulator are going to have an effect on the effective torque production of the PMSM machine. The output of these two regulators are the direct and quadrature voltages respectively. These reference voltages shall be further transformed to the three-phase coordinate system, where the three-phase inverter can realize the needed average values of these signals using PWM technique. Finally, I have brought an example of a common regulator block diagram representation that shall look very similar in case of a MATLAB Simulink implementation. As we know, the input of the regulator is some kind of an error signal, which is interpreted as the difference of the reference and control signals. Afterwards, this error signal is being multiplied by the proportional gain directly, which is added to the output of the integrator. The output of the PI controller is the sum of the proportional and integral gain operations together. Afterwards, saturation limitations shall be included in the implementation as well to ensure that the controlled physical quantity stays within the boundaries that the system defines. For an example, the direct and quadrature controller's output are the voltage signals interpreted in the relevant directions. Our model system are going to have a certain voltage level supply either from a battery or from a power network. Anyway, this nominal voltage value is going to be a boundary for our system, which means that we shall ensure that the current controllers do not output higher voltage references than the available DC-link voltage value. The same saturation need is going to be present in the previously mentioned speed control as well. However, the limitations there is going to be the maximum rotational speed of the PMSM motor.